You know that feeling, right? You've done all the revision, you know your stuff, but when you get your exam paper back, you just didn't get the full marks. Well, today we're going to crack the code on a tricky GCSE transformations question, and here's the secret. We're going to think like the examiner. Let's dive in.
So here's the big question. How do you guarantee you're getting every single mark on a complex geometry question? That's exactly what we're going to break down. I'm going to show you the exact method to bag every last point, because we're going to focus on what the mark scheme actually wants to see.
Okay, let's get into the problem itself. It's what I like to call the transformation puzzle. The question is simple, but the answer needs to be precise. What is the single move that gets triangle A to triangle C?
All right, so here's what the question tells us. First, triangle A gets reflected in the line x equals 1 to become triangle B. Then, triangle B gets reflected in the line y equals 2, and that gives us triangle C. So it's a two-step journey. But the real challenge? We need to find one single move that does the same job. So let's actually do these reflections and see where we end up.
All right, now this is super important. We're going to follow the method. Why? Because this is how you secure that first crucial mark. And here's a little exam secret for you. You can actually start scoring points before you even know the final answer. It's all about showing you're working.
And look, don't just take my word for it. This is straight from the official Pearson Edexcel mark scheme. It says M1 for triangle B drawn or for triangle C drawn. That M1 stands for a method mark. So literally, just by drawing one of those steps correctly, boom, you've got a mark in the bag. It's that easy.
Okay, step 1. We take our starting shape, triangle A, and we reflect it in that vertical line x equals 1. And what do we get? We get this intermediate shape, triangle B. And just to be super precise, the mark scheme confirms the vertices are at 4, 0, 4, -2, and 3, -2. Get that on your grid, and you've just earned that M1 mark.
Now, for step 2, we take our new triangle B and reflect that in the horizontal line y equals 2. And there we have it, our final destination, triangle C. So see, just by following the steps and drawing what the question tells you to draw, you've already put a point on the board.
So, we've done the drawing part. Now it's time for the main event, crafting the perfect answer. This is where we describe that single transformation, and this is how we're going to get the rest of the marks, the big ones.
Okay, so take a look. We've got our starting point A and our endpoint C. What's the single move that connects them? Well, you can see it's been turned, right? And here's a really useful bit of geometry trivia for you. 2 reflections and lines that cross will always equal a single rotation. So now our job is to describe that rotation perfectly.
To get every single accuracy mark for this, you need a 3-part answer. It's like a checklist. First, what's the transformation type? It's a rotation. Second, what's the angle and direction? That's 90 degrees clockwise. And third, and this is the one people often forget, where's the center point? It's at -4, 1. You need all 3.
And once again, let's go straight to the source. The mark scheme says A2 for rotation 90 degrees clockwise, center -4, 1. That A2 means you get 2 accuracy marks for nailing that exact description. That right there is your full marks answer.
But what if you're not 100% sure about all 3 parts? Well, good news. The mark scheme has a safety net. It says A1 for any 2 of the 3 aspects. That means you can still get 1 accuracy mark just for getting 2 out of 3 right. So let's say you knew it was a rotation and you found the center point, but you messed up the angle. You still get a mark. The lesson? Always write down what you know.
Okay, we're not quite done yet. Let's talk about all the valid solutions. Because sometimes in math, there's more than one way to be right. And this question is a perfect example of that. Think about it. Turning something 90 degrees clockwise gets it to the same spot as turning it 270 degrees anti-clockwise, right? It's the same end result. And because they describe the exact same rotation, the mark scheme accepts both answers as fully correct.
And here's the proof, black and white, right from the official document. It literally says, except 270 degrees anti-clockwise. So this isn't just a loophole. It's a recognized, valid alternative. Examiners are ready for it.
So, let's wrap this up with the key takeaways. Number 1, always show you're working. Draw the steps. It's the easiest way to get that first method mark. 2, a perfect rotation answer needs those 3 magic ingredients: the type, the angle with direction, and the center point. 3, never leave a question blank. You can get partial marks for a partially right answer. And 4, Remember that sometimes there's more than one correct way to say the same thing, like 90 degrees clockwise versus 270 anti-clockwise.
So, now you know how to think like an examiner, not just a student. The next time a transformations problem pops up on a paper, what's the very first thing you're going to do? Are you going to make sure you've locked in that method mark by showing your work? That kind of strategic thinking is how you make sure you get every single point you deserve.